We are now focusing on the solar system. To start our solar system unit off, we're going to focus on the sun. Our sun is the central body of our solar system. It is a normal G2 yellow star, and the main components of the sun is hydrogen and helium. Hydrogen making up the majority of the chemical composition of the sun. The sun produces and gives off its own light, its own energy. Our Earth would not be able to survive if it was closer or too far away, pointing to a creator God. Not only is the sun made up of hydrogen and helium, but the sun also does something very similar that the Earth does. It rotates. Rotation refers to spinning. So the sun actually spins. Now, make sure you don't confuse rotation with revolution. Rotation meaning spinning, while revolution means going around something. The moon revolves around the Earth. The Earth revolves around the sun. This is a comparison of size of the planets compared to the sun. This page is a page that you do need to be aware of. You need to be aware of the parts of the sun. We're going to start off with the corona, then we're going to work our way from the outside corona down into the inside of the sun, which ends with the core. So we're going external to internal. The corona is going to be the light area on the outside. Then we're going to move into the chromosphere, photosphere, convection, radiation zone or radiative zone, and then the core. So let's take a look at this. I'm going to summarize each one of these. Please put these on index cards. You will need to know the parts of the sun. And just like the Earth, the sun has layers. The corona is the glow, the outside, outermost structure of the sun. When we have a solar eclipse, what you see is the corona, the outside glow of the sun, this bright light. Then, more internal would be the chromosphere. Chrome means color. This is a reddish gas that's above the photosphere, but below or more internal than the corona. The chromosphere and the corona make up the stars or the sun's outer atmosphere. Then we move to the photosphere. Photo referring to light. The photosphere is the bright, shining envelope where light and heat will radiate. Then we have the convection zone. You learn what convection refers to, a rising and falling of heat. This actually is going to be a rising and falling of energy. Then we have the large majority of the sun, which is the radiation zone or radiative zone. This is basically giving off of energy. And then the most internal will be the core, and you can take a look at this. Now, we did talk about summer solstices. We did talk about the winter and summer solstice. We did talk about the winter and summer seasons in the past. As the Earth is tilted on its axis, the sun directly lines up on either the Tropic of Capricorn, giving us the northern hemisphere its winter, or it lines up on the Tropic of Cancer, giving the northern hemisphere its summer. So the sun is very important. Now, when the Earth is directly lined up with the sun's rays hitting the equator, then that would give us our equinoxes. Equa, think of equal. Now, the sun also does spin, also does rotate. But what's really interesting is that it's going to be spinning differently than how the Earth spins. The equator actually spins faster than the poles, which doesn't really make a lot of sense. If you think about it, okay, the poles, smaller distance, should be spinning faster, but for the sun, it doesn't. It spins about 35 days compared to an equatorial 25 days. This is actually called differential rotation. This actually impacts sunspots and different solar activities. Now, scientists theorize the relative temperature of the sun. Now, remember, this is a theory. We don't know for sure, but they do believe that it is actually colder in the sun's internal structure. Now, the sun's magnetic field will actually create magnetic loops, magnetic field lines, and these many times are filled with gas, and this can actually impact solar storms and solar flares. And we'll actually be looking at this later on in the slide. So this is on the sun's corona, on the outside layer. You have these loops these solar loops created by the sun's magnetic field. Now you also have solar minimums and solar maximums. These are actually impacted by the sun's magnetic field, and this is going to impact the size of the sunspots, the size of the different solar prominences, and solar flares. Now, a solar minimum would yield a smaller flare or smaller sunspot. Now, flares are actually close to the sunspots. Flare is going to be very similar to like a large explosion. And sunspots are usually going to be colder than other parts of the sun, usually look like little dots or black marks on the sun. But the solar minimum usually happens every 11 years, and I think the last one was around 2006, 2008, and then I believe the solar maximum was around 2014. And the solar maximums yield a larger sunspot or larger solar flares. Scientists actually theorized that it would be at a different time, and they actually found out that these solar sunspots in the solar maximum was actually smaller than what they expected it to be. As I said, the sunspots are these dark spots on the sun, usually a decrease or a drop of temperature, but compared to the sun's extreme temperatures, it's still very, very hot. And near these sunspots, you're going to have solar flares in different prominences. And as we said before, the temperature of the sun's atmosphere, basically, if we look at the photosphere, chromosphere to corona, it does get hotter the further out you go. But a lot of the internal structure of the sun is theory. We talked briefly about the solar prominences, such as the magnetic loops, and you can see the magnetic loops here, and within them you have those gases created by, gases within them, and these magnetic loops created by the sun's magnetic field. The solar flares, think of a large explosion, and as we said, they occur near sunspots. And here you can see a picture of the corona, the energy going around the sun, especially here is a solar eclipse. And the sun's corona is believed to be forever expanding, filling the solar system with a constant flow of solar wind. And solar wind is the continuous flow of charged particles, ions, electrons, neutrons, that comes from the sun in every direction.